My name is Hans-Jürgen Schönig, so Hans is totally sufficient. I've been doing Postgres database work all around the world for 27 years now. And yeah, I'm happy to welcome everyone. And yeah, I would say, Harry, over to you.
Thank you. Hey everyone, my name is Kiran. Been doing databases for the past 2 decades. That's the only thing I know. Don't know anything else other than databases. So fell in love with Postgres since 15 years, and I'm stuck to it. So love the Postgres ecosystem. Uh, been a great admirer of Hans and CYBERTEC's contribution to Postgres ecosystem. And at OpenSource DB, we closely partner with CYBERTEC and work in getting CYBERTEC into a lot more government-related projects, the MSMEs that are based out of India and Asia Pacific. Sovenath, you want to quickly give your introduction?
Yeah, hi, I am Sovenath. I manage the partner ecosystem for OpenSource DB. Very quickly on this entire Postgres Lakehouse, you must have recently heard about the acquisitions of Databricks acquiring Neon for $1 billion, Snowflake buying out Crunchy Data for a big number of money. So why are these new age data lake companies acquiring 29-year-old technology capabilities? Is Postgres Lakehouse a game changer? It is actually. So the hybrid transactional and analytical processing within a Postgres Lakehouse, it brings together two very important components: real-time transactional capabilities and analytical processing on the same data within a lakehouse structure, utilizing Postgres as the key component. This approach completely eliminates the traditional separation of operational databases and data warehouse, allowing immediate analytics on live transactional data. So with Lakehouse, it bridges the last critical gap, which is unifying transactions and analytics in an AI native way to one single platform, which is going to what we're going to talk about, CYBERTEC Lakehouse. So it's simplicity and speed all the way. I'll let Hans to take it up from here. Hans, over to you for CYBERTEC Lakehouse.
Sure. So before we dive into the actual product and the niche it brings to the market, we have a relatively new quorum here, Hans. If you can talk about CYBERTEC very briefly. I know it is very, very close to your heart. You have built this baby right from the infant stages. We'd love to know from Hans itself, to know what is CYBERTEC, what does it do to the Postgres ecosystem.
Yeah, so thank you, Harry, for this nice introduction. Basically, when I founded the company, I was something like 22 years old, right? So traditionally, CYBERTEC was coming out of an environment where we started off with data analytics, with labor market data in the Austrian economy. And I got in touch with Postgres in 1998, I believe. And I just stuck with the technology. I mean, back then it was no users, no nothing, no anything, So it was just me, no documentation, a little bit of source code, and that was it, right? But somehow it reached me, and we started to turn it into something useful. Let's put it that way. And this year we got 25th company anniversary, and we are serving Postgres customers around the world, everywhere. So this includes obviously India, this includes South Africa, Latin America. So every corner of the world, there is some kind of Postgres installation. This can be stuff such as nuclear test ban treaty. This can be credit cards. This can be rail systems. This can be payment. This can be medical. So Postgres is everywhere. And yeah, that's what we do. We are just pure Postgres fundamentalists. That's what we are. It's that simple. Right. Okay. Yeah, sorry.
No, I actually look at this in a couple of your conference titles. There are only two worthwhile, speed and instantaneous, and then CYBERTEC chose the first option. You want to throw some light on this?
I mean, yes, actually, yes. I saw this recently when flying back from South Africa, I think. I saw this quote by this Dutch mathematician, and I thought this is nice, because often if you're doing IT stuff, everything is in 5 years. If you go to many people in IT and you ask for something, the default answer is no, right? But
Yes.
imagine you go to the doctor and the default answer is no. That's not desirable. So I would say that if somebody has a request and it's not, you don't try to fix this with the mindset of dealing with it instantaneously, it's wrong by design. You know what I mean? So of course,
Yes.
stuff is with effort, but the mindset has to be, let's get this done. And not in 50 years we might start thinking about it. So this is why they struck me. Actually, that's the deep thought about that.
Awesome, awesome. So when we looked at, there are multiple. Sovenath mentioned about Databricks and Neon and Snowflake plus crunchy data. At a 10,000 feet overview. So what is Lakehouse for Scalefield?
Basically, what we're trying to do is not so much look at competition or what others are doing. What I'm primarily focused on is when I'm dealing with people around the world, which I'm still doing, what do those guys actually need? You know what I mean? So
Right.
I don't care what Oracle is doing, what others are doing. That's one perspective. But what people really need is they have a real world problem. And that is usually, okay, we want to be highly available, because if you go to the hospital at 3 a.m, you don't care about maintenance or whatever. You just want to be treated, right? So high availability is there because you want to have your phone 24/7. You want to have electricity 24/7. So that's one of the key requirements. Second key requirement is very simple. If you're looking at data, often you don't know how much you're going to get, right? So you launch a product, it could be a total disaster and you have no data, but sometimes it turns into a worldwide success and you have a lot of data, or things develop into a totally different direction. So scalability has to be at the core of the design, regardless if you need it, because you might need it. I mean, obviously, if you're running a desktop PC with your addresses, scalability is not an issue. But if you're, let's say, dealing with electrical data, 20 years ago, you had a list of customers and invoices. Now you got real-time data with 5 to 15 seconds resolution for every customer in the world. You know what I mean? So scalability has to be at least an option. And obviously, data is at the core of things, but first of all, it starts to be hybrid. So structured, unstructured, time series, transactional data, high durability, low durability, AI, non-AI, bookkeeping. It's so many different things that form a picture of data. So obviously, you also have to make it accessible, right? And accessible usually means make a chart, make an export, make a report, make something. So it's not like in the old days anymore when you had bookkeeping and that's it. But now it's like bookkeeping with customer feedback and image recognition and external data sources and currency exchange and fraud detection, right? It's not just bookkeeping anymore. It's in a reasonably sized company, everything starts to be more at scale, and you have to make things accessible to people which might not be, C programmers, let's say.
Right.
The idea is into one thing, not worrying about what everybody else does. Let's worry about what guys need, and that's the aim, at least, that is in my head.
Gotcha. So when we look at the Postgres and the Lakehouse, right, we are looking at fast, reliable transactions, and then at the same time, Lakehouse is actually giving us scalable analytics and asset compliance on the cloud if someone is using, and handles structured data versus supports semi-structured on the Lakehouse switch. Great.
It's a toolbox, really. Yeah. If you move on to the next slide, maybe.
Sure. Where am I?
Or can I do that on my
Yes,
own?
I'm here. I'm here.
Okay, cool. So if we look at the journey of data, obviously you have to load it, you have to store it in a reasonable way. Storing can be permanent for 20 years, or storing can be just a temporary thing. You never know.
Yeah.
You might see use cases in the car industry where data has to be stored for 20 plus years, because if an engine blows up 20 years later, you still want to know if you manufacture it properly, right? So storage can be short-term, long-term, whatever. Data ingestion can be a hybrid thing, or it can be a bulk load thing. And obviously, in the modern world, there is some reporting on top of that. Like something simple might turn out to be fairly complicated. How many customers do you have? Right? That sounds simple, but imagine you have a bank account and you share it with your wife. How many customers do you have? Right? You know? So things like that. So it's the world has become more complicated. Let's say. So we have to cover the journey from ingestion to storage to analytics, which can be as simple as counting, or analytics can be more complicated, such as fraud detection, which we'll show a bit later on this webinar. But basically, we have to cover the journey.
Yeah.
Okay, next one.
And when we are looking at how you are transforming the Postgres database to a knowledgeable information, there's this conundrum of things, right? Now I've got CYBERTEC, knowledge API, reporting, data science, right?
Yeah.
So for a Postgres engineer to digest this technology, how do you look at that, Hans?
We have to see that really as a toolbox, because obviously CYBERTEC is here for visualization. We'll see later in a moment how it works. Obviously, you need to integrate, and that in modern world means API. Obviously, you have to show to somebody, that is obviously reporting. And then obviously it's a hybrid set of data that comes in. So you might have time series data from a couple of sensors. You might have standard databases where you fetch data from Oracle, etc. So we really have to see this as a toolbox, and that it's not just a monolithic thing, but really a thing that combines various things into one technology, right? So this means filing port, it means efficient storage through column store. Just we have to keep in mind the world has become more complex, and it's not just a data source. It's a moloch of data sources. So yeah, that's mostly what we're talking about here.
Right. So when we are looking at so this is the object store, block storage, file system. The hybrid archives to high-speed storage. I guess that summarizes what we have in here. Now, you spoke about lake houses are directly, scalability is something that we should double click on. Right? You say beyond talk and price is reality. Now, what's your thought process here, Hans?
It's very simple. Let's imagine you're doing 1,000 lines a second. That's not something out of the world, right?
Yeah.
That means 86 million a day, right? 86 million a day. If you multiply that with 365 days, that is already 20 billion ballpark number. You know what I mean? So it adds up, and then you do this for 10 years, but then let's assume we made a mistake. It's not 1,000 rows a second. It's all of a sudden it's 10,000 rows a second because some compliance regulation came in.
Yes.
So if you extrapolate that, India is 1.4 billion people. Let's imagine everybody does 10 phone calls, That's 14 billion rows just because, and everybody's doing 10 phone calls a day, and you store them for 20 years, and, so this accumulates. You can have small data sets. There's nothing wrong with that, but you have to keep in mind that in some use cases, if you really run the numbers, this boils down to quite a lot of data, So we have to keep this in mind. And if you look at the slide you've seen before, it's really 1 trillion lines. That can actually happen, right?
Yeah.
This is a real screenshot. That's not fake. That's really something we did here. And in order to do that, you need to either have very efficient storage, you need scalable aggregation, and obviously, if you go to the next slide, you must be able to run things in parallel, because it's not about the CPU stuff, it's about the I/O. If you're reading 1 trillion lines of data, it means that you also have to read them from some type of storage, right? So it has to come from somewhere. It's not only about reading, it's not only about processing, you have to read it. So if you're reading at 1 gigabyte a second, 20 minutes is 1 terabyte. You have to keep that in mind. So if you're dealing with 100 terabytes, you cannot just click a button and wait. So you need parallel execution, you need asynchronous execution, like click a button and get back to me when you're done, right? Things like that.
So you're saying that the storage efficiency is an extremely important component of a whole of it. I know there are a couple of use cases. I would like you to piggyback on the Uber taxi rides. No, that's an enormous amount of data that you are saying. You want to talk about this?
Yeah, let's do both actually. The first one is Oracle audit logs, right? So imagine you have to audit a big organization for compliance or whatever. You keep adding audit, you keep adding, you have to store this for the regulators for years and years and years and years. And if you're in a big organization, storage starts to be expensive. If you, Harry, store pictures of your last family vacation, you go to Raj's hardware store, you buy yourself a hard drive and storage is free, Now get the same terabyte of storage in the biggest bank you could think of, and let's calculate the price of a terabyte of data, right?
Yeah.
And if you store this over years, obviously you have to be very compact. So the best thing I've seen so far in terms of compression was audit logs, because it's super redundant, which is 47:1. And if we talk about the Uber taxi rides, that's a public data set Uber has released some time ago, you really see that we're talking about 6:1, right? So somewhere between 5:1 and 1:40, So, but this matters because you can store it in a compact way. Everybody can read Parquet files. It's a technology known by data scientists. It's portable. It has metadata. It's not a fresh invention. It's something you can just give to your guys and they know most likely how to work with that. Okay, so as I said, we're not reinventing the wheel. We're combining technologies to make sure that you get the best of both worlds.
Gotcha.
Okay, go next.
So, sure.
Yeah. Okay. Harry, sorry to interrupt you.
No, I was saying, no, the automation of the whole piece is an extremely important component. And I see that, you guys have rocked in something called as Central Cockpit. What is that, Hans?
It's basically built on our CYBERTEC solution. Let me rehearse on that quickly. It's a low-code solution for Postgres that allows you to take data and visualize it, add a chart, add whatever. So we used our own tools to build our own tools, first of all. And what the cockpit really does is it gives you an overview of what's going on. Okay, so how much data is there? What is available? How was importing going? How is the system behaving? What is there for the operator to see? So which users are there? Which jobs are running? What have we imported? Etc. Etc. This can be customized because it's built through the local platform. But really the idea is to have a system where people can look on what's going on the system. Are we running out of space? What is running? Are we running 5,000 parallel aggregations, which makes no sense, or is everything nicely in order? Just to have a central overview of what's going on in the system. So that's what we have, because also it's also in the old days, somebody built solutions that made the customer happy. These days, you have to make the customer and the auditors happy, right? That's two people.
Yes.
Or that's two components already to the same story. So it's not only about the data and the application, it's also about the security reports, the compliance reports, the audit data you can get out of it, So it's catering to the end user and to the auditors. And the auditors might want a report on all the permissions and stuff like that. So central cockpit makes it accessible. That's the idea, right?
Got
Because
it.
we want
Got
to
it.
avoid too much human interaction, monkey tasks, stuff like that, just to push this forward, right? And here, for
Got
example, you can see, hey, how is my S3 bucket going? How is import going? This is again Oracle audit data that is processed here. You know, so that's really at the core to make things that are going on visible, because it's usually not one task, right? Because you're
Correct.
doing
Yeah.
prediction, you're doing analytics, you're doing, you know, stuff, right? And this is why you really want to integrate storage, oversight, et cetera, et cetera. Okay.
Great. Great. Now, moving on, we are looking at, I know we are pressing
Yeah.
against the time too. What do we? Yeah.
This is important. I mean,
Yeah.
everybody's talking AI. And if you go to a conference, everybody will secretly approach you. We want to do AI, tell me what to do.
Yeah.
You know, because they're all spoiled by some crazy marketing, like, oh, I can do everything. All I want is to manage a parking lot, you know, tell me how I can use that.
Right.
So we did a couple of experiments on, okay, feed the system your data structure and ask the system what you might want to know. Right? So
Right.
feed the system the structure, and the language model will tell you, hey, you might want to count customers, you might want to analyze average duration, you might want to do this, you might want to do that. So this is basically a way, just feed the data structure to the models and let it look at things you have in the lakehouse, and let the AI give you some ideas on what you might want to do with your data. Right?
Got
So
it.
that's the idea. Let's start with what can we do, right? So it's about, okay, we load some data, we store data, we compress it, we analyze it at scale. But the first question we logically have to answer is, hey, what can we do with this stuff at all? I mean, most people might know already, but there are some people that might, oh, just give us some inspiration. What do we have, and how can we make use of that? So that's the idea for a first simple application of applying a language model to just give me ideas. What can we do here?
Yeah.
Right?
Data to an actionable intelligence.
Exactly. So just tell me what you want. Okay, tell me what we can do. Give me a suggestion. Right?
Right.
So if you look further, I made a practical example on some data which we've loaded to show you what you can really make out of it. So what you're going to see here is a complete journey of a data set from ingestion to delivery.
Right.
Okay, so we load some data, and the idea is, because it's an obvious example, everybody can resonate with that, is let's do some fraud detection, because that's a bit more than just count and select and read, etc. So you need a bit more logic that falls into the category of data science and AI. And there's just a couple of mechanisms here we can find. So if you're doing data fraud detection, basically the first thing you do is you need to start to understand how your data is structured, what you have, and then it's often about anomaly detection, outliers, etc. And what we're going to see here is how we can combine this toolbox into useful output. Okay, so that's the journey. So let's go through this and see how this can be done. So I shamelessly borrowed a data set from a website called Kaggle, which is a very nice thing for everybody who is interested in data science, AI, data sets, samples, etc. So the first thing is obviously you have to ingest the data, right?
Ingest data, yes.
Yeah. So first of all, there is a Python library. Wait. Previous. There's a Python library that says, hey, download the data set for me and show me where it is. So it's a three-liner. You can obviously visualize that and paste the link, and but I just gave you the real thing that's going on behind the scenes. And when you load this into Postgres, you say create a table and load this data. That's it. Right? So that is data ingestion. You take a ready-made data set from Kaggle, 3 lines, which of course can be put on AI. Then you create a table, boom, next slide. You don't need to know anything about that. The cool thing is you don't need to know the structures. You don't have to, it's all done by the layer below. Then you have a table, you see the data structure, you notice that that's not exactly what you want. So you modify with a couple of SQL commands, to make this financially, to make this feasible for finance data. So now we got our data, and now we can work on fraud detection, right? So this is really a fairly quick process. So obviously what I advise you to do is when you start with data science, don't apply the heavy stuff quite yet. Get a feeling of data. How many rows do we have? How many different customers are there? Where do they come from? What's the distribution of gender, region, products, etc.? So that you first run some basic SQL just to see what there is. Okay, how many login requests did those guys have? How many different IP addresses? How many accounts are there? You know, what's the amount of money in the bank accounts? Just to get a feeling, because it will allow you to better judge your results. The worst thing you can do is just blindly apply something, and then you don't know if the data, the results you got are in a reasonable way, you know, if that actually makes sense, right? I've seen this too often, that people just blindly apply some stupid AI, take the result as the gospel, and then wonder what's going on here, right? So you need to have a feeling for data, and this is very easy because you can just run SQL, which most people might know, in order to get a handle on the data. Okay? So if you move on, it's called explorative analysis. What a wonderful word for running some basic SQL, right? So on the AI side of, on the UI side of things, what we have here is inside CYBERTEC, which is part of the Lakehouse thing, you can look at your data structure, right? So you can look at the data structure, and when you click on the next link, what you can do is, if you click on the next slide, what you can do is you can generate an application out of your data structure. So you just say, I want to visualize this, and that, to give the application a name. You select your data sources, you assign some permissions, and what the thing is going to do is it's going to create a simple application and gives you a WYSIWYG editor. What you see is what you get, which allows you to modify what you see. So put a chart here, change the metrics on the chart, add a table, add a form, etc., etc. So that's basically the component which allows you to visualize, make input forms, import, export, you know, just build yourself an application around the data. So we generated this on the previous slide. On this slide, we modify the application we've just generated. And if we move forward to the next one, once we have imported, generated some applications, etc., we can then move on to the real algorithms on the fraud detection side. So if you click on the next slide, so then once we have that, we can finally apply the logic, right? And just for the sake of the example, we took the data and ran some simple algorithms on this data, like a thing called k-means clustering, and then a thing called DB scan, right? I'll explain later what it means. So now, once we have the data, it's time to apply the data science, whatever it might be. Okay, so if we move on to the next one. K-means is a mechanism that allows you to group data, right? So imagine every person in the world is a point moving on the map, right? Where's the city? You know? Where's the city? Obviously where all the points are, right? So a clustering algorithm will allow you to group things that go together. Like here's a crowd of people, here is most cell phone activity. So it takes points in any dimension, you know, and just allows you to group them with a mathematical module. So the question is, how many groups do you want to have, right? How do you know? So got a ton of data. How many groups shall we make? And there's a thing called elbow method where you just check. You try various number of groups. You try with one group, which is obviously no sense. You try with 2 groups, 4 groups, blah, 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 right? And then you see how a thing called inertia develops. And the elbow method comes from take as many groups as you would see in your elbow. So when the curve starts to flatten out, that's usually a good number of groups. Okay, so that's how you would start that. So if you move on, I also shared the Python code here. So if you do this for real, you will see that there's a bunch of points here, and what Kamins will do is it will keep them in a group, right?
Gotcha.
So we show what this is, right? So this is something you can do. Obviously, you have the data in Postgres. You can run Python code for your analysis. You can do modules that are built into Postgres. There's also a K-means implementation for Postgres core, which you can run on SQL directly. So you can really combine a couple of toolboxes in a nice way. You can use build container for process isolation. You can use modules which are native to C. You can hook up with an R program. You can run R inside Postgres. You can run Python inside Postgres, stuff like that. So, but basically, you can just apply data science of your choice in order to make those calculations, right? So if we move on to the next one, so we make groups here, and there's some data going on here, and you see to which group every row belongs to. So if you look at the last column, that is class, not the last one, the one before the last one, it says cluster. When you run through all your data, you will see that the first couple of rows will belong to group number 0. Next guy belongs to group number 2, and so on and so on. So it takes some multidimensional data and puts it into different types of groups, right? And if you look at the visualization, you will see that each of those groups has a center, right? And what we can do now in order to find outliers is, okay, we put you into a group, but how well do you actually fit into this group? Are you an outlier? Are you a suspicious transaction? That's what it says. So we're grouping transactions into stuff, and everybody who is too far away from some group, let's say, is an outlier. So this is a suspicious transaction. That's what we're doing here. So we're loading data, we're clustering it into groups, and then we check how far are you away from sanity, right?
Got it.
You belong to group transactions A, B, C, D, E, but you know, my friend, 1 rupee sent to Tajikistan, you know, might be suspicious. It's not the typical data set. So what we try to find the difference between the common transaction and the outliers. And we can combine algorithms. So if we move on to the next one.
While we are here, Hans, right now, I'd like to see if there are any questions up until now.
No questions as such on the chat box as of now. But Hans, I have one question. So
sure.
all this pieces that the data sciences team will do, they can run it from the UI on Scalefield or CYBERTEC?
You can visualize in the UI. You can obviously always build a UI around stuff because the toolbox to build it is there. Obviously, the data science thing is so diverse. You will need so many different things that you would actually plug in different code fragments to run this. For example, you could make a function that extracts, I don't know, credit risk. You know, there is no such thing as a UI that can magically do credit risk. It's a more complicated thing. So what you're doing here is you're using the UI to have the workflows going, to have the imports going, to do job scheduling, to see what is running, to visualize the data, to expose the data as API. For this hardcore stuff here, you always have to write a couple of lines of code because no UI in the world could cover that in a useful way to give you the options, right? What we have is the opportunity, obviously, to run some stuff through the UI, but that would be trivial stuff. If you're running like a multidimensional regression, whatever, you need to plug in the logic, like interest payment calculation, derivative value calculation, you know, you have some time series and you calculate volatility, you know, there's a library that calculates volatility on stock markets, stuff like that. So
to include the libraries, So to
Yes.
include the libraries, the editor can what you see and what you get editor can be used. Is that a
It depends. I mean, this is just Python functions. In this case, it's just Python functions because I recently saw a book on derivative pricing, options, stuff like that. It's this size, just options pricing and derivatives. It's that kind of book, 600 pages. So it's more complicated if you're dealing with this kind of data like a credit risk and stuff like that, and let's say fraud, etc. There is no out of the box algorithm, so you have to combine them, and you have to see, okay, this column has to be normalized. Okay, it's simple stuff like you group by country, but you have wrong encodings, like disputed borders and stuff like that.
Understood.
Yeah.
Very well. Very well.
Okay, let's apply some more algorithms on the data to see how this works.
Sure.
Yeah, this is just a compilation of how you would, which algorithms you might want to use. It's all readily available. So you got DB scan, which can do nested clusters, and k-means, which would group them. And I recently saw a paper from University of Helsinki, which did consensus algorithms about over cluster algorithms and stuff like that. So you can apply really all the logic you want. You can use everything that is out there in the world, like sklearn or PyTorch, or, all this stuff, and you can just combine it. And fortunately, there are very nice mechanism which allows you to quickly take data from Postgres and put the results back into Postgres so that you can visualize it with Cybex, exposes an API. So what you really do is like a data frame dot to SQL, and it materializes as a table, so that it can quickly visualize and quickly put it back, join it, export it, put it on the map and something like that. So the central platform is Postgres in a scalable way. Then there is logic, which you can put in at every possible corner. And then there is the visualization side where you can make forms, configurations, displays, etc. Configure your scheduler, see which imports are running, schedule the import, stuff like that. Manage a scheduler, which is feature timetable, things like that. Okay.
Right.
So next one.
Moving on and adding additional algorithms. So yeah, there you go. That's the key benefits that would you mind giving us a holistic picture of this key benefits?
The beauty of a relational database is that data quality is superior. You know what you have, right?
Yeah.
That's a good thing. You've got 5 columns, you know what it is, you can work with that, right? So that's the foundation. So if a full-blown database that scales, that can be replicated, that can be backup, that can have permissions, that can run complex stuff, that can scale, right? It has column storage, row storage, all the magic there is. So you have this full power of Postgres. That's important, including JSON stuff, etc., including all the import logic, which I've shown before, with a couple of extensions and stuff. The next thing you have is the full visualization through Cybex, which allows you to make. Nobody wants a database. What you want is an application.
Right.
Exactly. Can you go back to the benefits? So what you really want is an application. Nobody wants a database. You want bookkeeping, you want a ticket shop, you want measurements. You don't want a database, you want an application, right? Or you want the results or something like that. So what you do here is really you have to visualize everything. Can you just stay on the slide for a second? Yeah. No, the other one? Yeah. So you can make your applications. The next thing inside Scalefield is it provides you with the full automation of stuff. So create a database, create a replica, launch a UI, launch a migrator. So basically you have a full-blown database with a full UI stuff and the full automation that can run on Kubernetes, on OpenShift, on-prem, on cloud, on VM, on plain iron, whatever you want. So it's really the integration. It's the scalability side, it's the UI side, and it's the automation. So it's not like, oh, I have to install a database. No, you visually create a database, you have the modules there, and obviously you can create the UI on top of that by full automation. That is important because if you're dealing with a large organization, there is no such thing as an application. There's only applications, data, project teams, requirements. There's no such thing as, oh, Lakehouse, one application. No, it's usually many people working on subsets of data, pipelines. So you might have financial data, which goes to fraud detection, financial data, which goes to credit risk evaluation, financial data that goes to real estate evaluation, and you have to make sure that you can bring those guys together and work in an infrastructure that has single sign-on, has monitoring, has automation, has scalability, so to take away the pain of these monkey tasks, right?
Gotcha.
So that's what you're really talking about here. Okay, so next one. Okay, so I was talking about visualization already. If you move on to the next one. So what we have inside Scalefield is basically we have Postgres Enterprise Edition, Migrator, so to get data from Oracle, etc. We have the full visualization and an MS SQL compatible service, so that you can basically save a license run. And obviously, there is the Lakehouse is basically one part of the complete Scalefield deployment that comes with the cockpit, with all the extensions there, etc. But it's part of bigger automation and bigger deployment and high availability and things like that. And on top of that, there is a thing which is not on the slide yet, which I want to mention. It's called Scalefield Secure. It's going to give you one compliance report for the whole thing. So you automate your database deployment, you have your Lakehouse, you have your migration stuff, you have your graphical user interface, you have your MS SQL compatible service, and you have one compliance report for the whole thing, right? This is important for banking, infrastructure, everything that is regulated, basically. Okay? So as you can see on the next slide here,
one quick question on this piece, the whole of Scalefield as one product, Hans. So people have been using Babelfish for PostgreSQL. With the Scalefield, making all of these into one component, is it the Babelfish forked version, or you have the open source part of this?
It's the open source version plus the PGE stuff for on-disk encryption,
right,
optimizer extension, stuff like that.
Right. So
because we have to maintain the encryption for compliance, so we added the PGE component for that, for a couple of things we need for the compliance side.
Great, cool.
So that's what it looks like, if you create a database, it's like self-service portal. And yeah, any questions, anybody? Most welcome.
This is at a record space, I would say, Hans. We're 45 minutes into the call, and we could get as many questions as possible. Guys, this is your time to go ahead and ask any questions to Hans or myself. Any questions on the chat, Sovenath?
No, not. I have one question here. How does CYBERTEC Lakehouse handle data ingestion?
Ingestion. Okay. Yes. So the way it works is basically you can use everything that Postgres can provide, like copy, insert, whatever, but there are more ways to that. You can ingest via API. So everything that is marked as a data source in CYBEX is also a REST endpoint. So let's imagine you take a table and you tell CYBEX, expose it as API for us, allows you to turn everything there is also into an API for reading and writing. So for example, if you take this table and inside the CYBERTEC CI, you mark it as a default view or whatever it is, it allows you to have the API side covered. Postgres allows you to have all the other stuffs covered. And if you go one slide back, you're wondering if you do create table here as whatever, how does it know the structure? Where does the data structure come from? There's a module that is loaded into this. It's called DuckDB that basically allows you to ingest from everywhere. So you can have API side of things through CYBERTEC. You can have Postgres means, or you can have a couple of modules that are loaded into Postgres to read packets, to read stuff, right?
Yeah. Yes, we said stuff.
Yeah. And obviously you can write yourself a program and do whatever you want, So, but that's the not so cool stuff. Usually you just want to load directly. For orchestration, this is important also. It's not just about the loading part, it's also about the processing part in general. Everything is based on a thing called PG timetable, which is a scheduler for Postgres.
Right.
This stuff has a couple of features which were explicitly made years ago with things like that in mind. For example, concurrency protection. Let's imagine you're running analytics every day. So every day at midnight, you want to start some analytics. What happens if if this takes 27 hours? You would start to die, Or imagine a scheduler would start to import data before the last import is done. You would die, right? Inevitably. So what PG timetable can do, for example, is make sure that one type of job is only run once at a time and it retries 5 times before it stops, or make sure this only runs 7 times concurrently. You can also say run it once and die. For example, if you click on a button in the UI and it takes 3 minutes to calculate, your UI will time out, right?
Right.
And do that. So what PG timetable can do is we can have a button that says run this and get back to me when you're done. This is a self-destruction job. Run it once, run it as often until it's successful, or stop after 5 times so that you can do asynchronous execution. So the import part is not just the way you can import it, it's also about the orchestration of import and aggregation. So import this, aggregate it, and send an email, That's called a chain. And we do all kinds of concurrency protection. We can have remote chains so that we can orchestrate various servers, things like that. And so this ingestion, aggregation, and analytics part is all held together through a scheduling module that can be configured graphically.
Great. So, Hans, there are quite a few folks who are interested in trying CYBERTEC Lakehouse, right? What are the options we have at this point of time?
So what we can do here is we schedule one-on-one meetings, right? And we sit together, we talk about what you have, what you need, then we show on the systems how things work, and we have all the deployments there so that we see what is best for you. Because sometimes it's an overkill, sometimes it's a scaling issue, sometimes it's more a visualization thing. So we need to understand, we show this, we draft in a one-on-one session, we prototype this, so click through that, etc. We toyed with the idea of a trial, but the problem is it's so massive in functionality.
Right.
It's like, I'll give you an SAP trial. Come on and try bookkeeping, It's very complicated. So we do this in an assisted way. So we do a one-on-one, we work together, we show you on the UI how to run this, so you can understand how this works. We do a tiny test case together, maybe POC or something. So this is done in an assisted way.
Got it. Thank you.
Because something like, let's do consensus over cluster algorithms, come on, do it on your own, figure out, right? That's tricky, right?
Got it.
So one question from my side, Hans, when it comes to deploying the Lakehouse. So is it the same Scalefield UI which gets leveraged so that the deployment gets done in a Docker manner? How does it work?
So the deployment works like this. You deploy Scalefield, that is for creating instances, backups, changing configuration, deploying side-packs, all this stuff. And the Lakehouse is an application inside Scalefield that is based on side-packs and has a special image in the containers with all the extensions. So basically, we install a side-packs application, we deploy a couple of more things optionally, depends on what you needed, like as a rook operator for S3. We deploy, what there is. So it's inside Scalefield. Everything is based on containers. And depending on which storage do you need? Do you need S3 buckets? Do you need whatever? So you can change that a bit. So do you need Oracle migration? You can provision a migrator that feeds into your Lakehouse servers, stuff like that. It's also a scale question, how you deploy this. So is this going to be one database that is small? Is it going to be one database that is large? Or does it have to be, like 20 servers collecting data, 50 servers processing data, 3 servers displaying data, right? So it depends a bit on how your data flow works and how the scale works. So it's not like deploy everything, whatever. So it's really like you have to see how much data do you have. How is this in the same place geographically? Can you get it over the wire? It's one thing to process 100 terabytes of data. A second problem is to get them where you want them. Right? So you have 100,000 lines a second in the South Pacific, and you want to ship it to Greenland. Things like that. So there's a whole process to this. But basically, it's deployed through containers. It can be single database, it can be 60 shards, it can be multiple aggregation clusters. We recently had something for a compliance project where we basically had 4 or 5 aggregation clusters for the audit data, depending on database engine and stuff like that. Right? It's different data sources that feed into the central dashboard. Retention.
So with reference to, yes, loading data could be difficult, but deploying the Lakehouse, deploying Postgres, it seems to be pretty straightforward with Scalefield, with the Docker images.
Yeah, the deploying Scalefield is relatively simple. Obviously, there are some components you have to keep in mind, like who is allowed to do this? You deploy the thing, but do you want single sign-on in your organization? Who is allowed to set the sizes of the servers? Who gets the alerts? So this is always a integration. So deploying Postgres, easy cake. Backup, easy cake. Cluster scaling, that's all easy cake. But the fun part is like you got an organization that is deploying 1,000 servers. Are they in the same cost center? Who is allowed to see what? Compliance, storage. What is a big? What is a small? Who is allowed to do this data science stuff? Privacy, things like that. So the options are all there. It's just important to understand that this is full stack Postgres essentially. This is full stack Postgres that comes with automation, database, scalability, database infrastructure, compliance, encryption, UI, import, export, scheduling. So this is full stack Postgres. That's what we're really talking about here. It's everything from deployment to automation to AI to visualization. Full stack Postgres. That's what we're talking about here.
Very well, very well. We'll just throw the forum open we got a couple of minutes before we go to the clock. If there are any questions, please put it in the chat. We'll be happy to answer them. Hans, till the time we get the questions, I have one question for you again. Can you talk about one of your big customers where you have seen like massive oceans of servers?
Oceans of servers. Our biggest customer at the moment, where we know roughly the numbers, is German car industry. Let's call them BMW. Let's say. So they're running thousands of servers, right? If you're talking about critical applications, we're talking about German passports and embassies. We're talking about test ban treaty. We're talking about Swiss Railway. We're talking about national bank, like Swiss National Bank, Austrian National Bank. We're talking about e-government in various countries. We're talking about phone providers. I mean, just dream up some of the big names, and you most likely will find them. So on data sizes, you have everything from a couple of megabytes all the way up to the biggest one I've seen personally, meaning myself, is a single instance 170 terabytes of data. But some colleagues have seen more, But it all depends on, is this compressed, non-compressed, time series, but thousands of servers. And this is why I'm so focused on orchestration. You cannot go and manually deploy 1,000 servers. Forget it.
Right.
Don't do this. Right. So what it would do is orchestration, automation, a process. Okay.
Those are the drivers for scalability, I would say.
Yeah, absolutely. I mean, absolutely, and also a cost saving. It's not only about cost. It's also about availability of labor. How many DB2 experts do you expect to find in southern France? Or choose any country.
Yeah.
So yeah.
I think we are at the top of the hour. Thanks, Hans. Thanks, Hari, for making this session interactive. And this really opens up what CYBERTEC can do in the Lakehouse space. And Lakehouse is becoming very, very interesting. And then there's a huge adoption which is happening steadily. People are realizing that Postgres is the home for both OLTP and OLAP, and that's the roads are merging. Anybody, any questions, feel free to let us know. Send us an email. We'll be happy to respond to you. Anything that you want to know more about us, we'll be again happy to respond to you, and we'll jump on a call with you guys. Thanks so much, Hans. Thanks so much, Hari. It was a great session. Thanks, ladies and gentlemen. Thank you for your time.
And thanks to our favorite partners who made this happen, So very much thank you to you, Hari, and Sovenath. So we're super, super happy. So very happy to have you guys on board. It has been a pleasure, I have to say. So for everybody on the call, please reach out to those guys. I can just warmly recommend dealing with those people. So it's just excellent.
Great. Sure. Thank you, everyone.
Thank you, everyone. Thank you.